Hey friends, we are still in chapter 8. We're looking at functions and graphing, and today we're looking specifically at a very important algebraic concept that you're going to use forever and ever in your math career. We're going to talk about slope. And slope, we've talked about in terms of rate and change. Slope is ultimately rate and change, rate of change. And here we have the definition. Slope is the ratio, not ration, sorry, is the ratio of the change in y, vertical change, that's also called the rise, over the change in x, that's the horizontal change, it's called the run. And I meant to highlight that blue, but that didn't happen. All right, so rise and run. And so this is the definition, but let's go ahead and look at the ratios that we're going to talk about. So we often call it rise over run. You remember in the last section we referred to it as delta y over delta x, or the change in y over the change in x. We're going to call it the vertical change over the horizontal change. We should also call it, what did we say, rate of change. In general, this is just the rate of change. So slope is referred to as a lot of things. Another one is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We're going to talk about this in our last example. And finally, the variable that is used to represent slope is m. So when you have a linear equation, oftentimes you might see y equals mx plus b as the representative of a linear equation. This is a linear equation in a particular form called the slope-intercept form. We'll get to that later. But the m refers to the slope here. Ooh, the m refers to the slope. Sorry about the jumpy screen, friends. All right. So with that in mind, so we've got all of these concepts, and with that in mind, we're going to apply this to a couple of examples. So here in example, let me see if I can get the screen. There we go. Here in example 1, we're going to use the rise and run to find the slope. The rise and run, or the rise over run. Find the slope of the incline that the car is driving up. So we've got this car driving up. Actually, I think these are stairs if you look closely. And it's about 18 feet in terms of the horizontal direction and 12 feet in terms of the vertical direction. I actually put these numbers in. I don't really know. That would be crazy. I wouldn't do that. But anyway, so if this is the relationship in this incline to its vertical and its horizontal height, or its vertical and horizontal height, what would the slope be? So you know we have several definitions of slope that we've been talking about. So slope, we're using m as a variable, but slope, we can use rise over run, change in y over change in x, you know, a number of different things from our last definition. Let us simply use rise over run, where we recognize rise to be the vertical lift and the run to be the horizontal. So if we're going to use rise over run, our vertical lift is 12 feet and our horizontal movement is 18 feet. And so with that in mind, our slope is 12 over 18. We don't have to write the units. And what we realize is that we can reduce this, and that's simply the fact that 6 is a factor of both numbers. So we end up with 2 over 3. So the slope is a 2 over 3 gradient, or a 2 over 3 slope. And so that's what we have here. All right, let's see if we have another example. Oh, check this out. So for example 2, what we're going to do is find the slope of all of these lines, okay? So we have 1, 2, 3, 4, 5 lines. I'm going to look here and we're going to find the slope here. If you notice that this particular example, so we're looking at lines, and what we have is we're picking 2 points on the line. Any 2 points will do. As we mentioned before in the last section, any 2 points, if I realize I have like this relationship that's linear, will give you the slope. So the 2 points that are picked for us here in this example would be -2, -1, and 4, 3. So remember, we're looking for the slope. So we're going to find the change in y over change in x. And sometimes I write this as delta y over delta x. That Greek letter means change. And so when I think about change, I need to think about what's happening for the y coordinates as I go from -2, oh no, sorry, as I go from -1, that's the y, all the way up to +3. So when I think about that, I'm thinking about the difference between 3 and -1. So I say 3 minus a -1. That's the change in y. that changes the difference. Then I'm going to have to do the change in x. Since I was considering this point first when I was thinking about the change in terms of the ordered pairs that I was using, I'm going to use this x value 4 first. That order needs to be maintained, and I talked about that a lot in the last video. So 4 minus a minus 2. So 4 minus a minus 2. When I do that, I end up with 4 over 6, which can easily be reduced to 2 over 3. Look at that, it came up again. So the slope of this line is 2 over 3. Let's come over here and find the slopes of line A, B, C, and D. And notice this picture already has 2 points indicated for us. You don't have to use those 2 points. You can use any 2 points that you perceive to be on the line. But these 2 points, hopefully we'll be able to find coordinate values that'll help us out. So for A, the 2 points that I see that I have here would be -7 for the x in this coordinate here, and a +2. So I've got -7, 2. That negative's not looking quite negative, so I'm going to just try to make that look a little bit better. So -7, 2 is what I've got. And then over here, I have -3, 4. If I'm going to find the slope, I'm going to do change in y over change in x, the difference between the y terms over the difference between the x terms. So I've chosen to say 4 minus 2 over -3 minus -7, -3 minus a -7. Sorry, that's gotten into the grass there. 4 minus 2 is 2. -3 minus a -7 is really -3 plus 7, which becomes 4. The slope of this is 1/2. So I'll put the slope right here. The slope of A, m is equal to 1/2. Let's do B. So if I'm looking at B, I need to identify what these coordinates are. This one is 2, 4. This point here will be 6, -2. And again, the process is the same. To find the slope of B, change in y over change in x, I'm going to use this one, 4 minus a minus 2. So I'm saying 4 minus a minus 2, which is really 4 plus 2. So 4 minus a minus 2 over 2 minus 6. 4 minus a minus 2 is 4 plus 2, which is 6. 2 minus 6 is -4. And my answer, let's see if I can get some more space. And my answer for this one, I'm going to put an arrow here so you know what I'm doing. My answer for this one is going to be -3 over 2. Yes, we could write that as -1.5, but with slope, it really is beneficial to leave it as an improper fraction. So yes, we could do -1.5, we could do -1.5, but it really is best to leave slope as a improper fraction when we can. So C and D are going to be valuable situations that we need to keep in mind. So as I look at C, this one is C over here, as I look at C, the 2 points that I'm dealing with are -4, -6. And over here, I have a +3 and -6 again. So the change in y will be -6 minus a -6. And the change in x will be, well, let's say I'm looking from here to here, 3 minus a -4. -6 minus a -6 is -6 plus 6, which is 0, and 3 minus a -4 is 3 plus 4, which is 7. What this tells me, 0 over 7 is 7, is that this is a 0 slope. And notice the key here was that there was no change in the y, which gave me that 0 slope. Meaning, when you have a line where all the points are on the same y value, right? So all these points will have the same y value of -6. There is no change. So a horizontal line, that's what this is. A horizontal line has a slope of 0. That's a key point, and you want to keep that, write that down. Horizontal line has a slope of 0. Part D, or line D, we're going to look at this guy. The ordered pairs here are -7 and -3, I think. And the ordered pair here would be -7 and I think -5. As I look at these guys, I'm going to do change in y over change in x. The change in y, I had -3. I think I'm trying to do a -5 here. So let's say -5 minus a -3 as my change in y value over -7 minus 7. minus a negative 7 that is, which turns into a plus, which turns into a 0 in the denominator, and right? Because we're not allowed to divide by 0, right? Aren't you like, oh my gosh, Deanna, what's going on? You should be. We're not allowed to divide by 0. Doesn't matter what 2 points I choose here. Every time I find the change in x, there won't be any because the x value is the same. So anytime I have a line like this, which is a vertical line, I'm going to get this situation. I want you to be scared, and I want you to remember this. What I want you to remember is that this is an undefined slope. It's not a 0 slope. It doesn't have a slope. It is undefined. So up in the numerator, I'm going to get a negative 2, which is irrelevant. I can divide no number by 0. So I write undefined. Okay? It does not have a slope. No slope, not having a slope, undefined, is not the same as having a 0 slope. All right? Another key point. Finally, my little chablitos, we have this last example. And it's example 3 where we're going to find the slopes given ordered pairs. And really, I'm just going to do one of these because I think you guys have got the picture. And this kind of shows us why we had that equation for slope that was y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The reason why we had that is because if you look at one slope and one point and you call it P1 and the next one you call it P2, what you do when you think about the change in y and change in x is you want to make sure and keep order. And the order that you need to maintain is helpful to call the point 1 x1 y1 and point 2 x2 y2. And then you just plug it into this formula. 2, got it, because that's y2, minus 3 over x sub 2, which is negative 6. And that's minus a minus 4. And the reason why I'm showing you this is so you understand where the definition comes from. But we've been doing this even since the last section when we were talking about rate of change. So 2 minus 3 gives me a negative 1. Negative 6 minus a minus 4 is really negative 6 plus 4 is really negative 2. And that, the slope is 1/2, positive 1/2. And I'm going to stop there. I think that's enough. If you guys want to try the other ones, that'll be great. Great check, and we can talk about what the answers are, or maybe in a second I'll just pause it and give you the answer. I'll do that. I'm going to pause it and give you the answers. So have a good one. Look forward to seeing you, and you can pause me now because I'm about to give you the answers. All right, so here's your answers. -1 for this example through these 2 points. Undefined through these 2 points. Notice there's no change in the x value. And over here, it's going to be a positive 2. Can't wait to see you guys tomorrow. Please have some questions for me and do your best with the assignment. All right, take it easy. Bye-bye.